you want to take care of what is inside the parentheses first is just one simple way. Okay, reducing 2 over 8 is 1/4. Then x to the 4th, y cubed to the 3rd. Now you're raising all 3, even 1 as well, to the 3rd power, so you're multiplying. Y to the 9th, 4 cubed, x to the 12th, y to the 9th, 64, x to the 12th. By this point, we should know what 4 cubed is, okay, no matter what. And you had no calculator, but you should know how to simplify that by now, okay? The next two, again, very straightforward. 27 to the 2/3 is the cube root of 27 squared, which we should know of. What's the cube root of 27? 3 squared. 9. Okay. Then the last one, number 3, I mean. Okay. Negative exponent does not mean that fraction is the reciprocal. Okay. You rewrite it in radical notation. The cube root of 125 to the negative second. What's the cube root of 125? 5. 5 to the negative second, what happens with a negative exponent? Where does it go? Denominator. Then we have 5 squared, 1 over 25. Okay? So the first 3 were pretty much like your first formative. Okay? Was exactly the same. Just different numbers. Then the last 3, which was 5.3, which we just learned, just finished. Okay, we did the calculator stuff. Now, here was the non-calc. So, biggest mistakes that I saw throughout, oops, was dividing by 4 first. Okay, these are together through addition and subtraction. So you subtract 4. Equals 32. Now, some of you from here took the 5th root of both sides. You still have a negative 1 in front. You want to isolate this first. So divide by negative 1 equals negative 32. And you can take an odd root of a negative number. You're automatically going to get a negative solution. And you end up negative 4, which works. Okay? Number 5, biggest mistake was forgetting the plus or minus. Because one of the rules when we take an even root to both sides, you must include the plus or minus, and they both work. Okay? And then the last one, which I believe a lot of you did get correct. Okay? We have to square both sides. We end up with 3x plus 7. This is FOILed out, so x squared plus 2x plus 1. Okay? Since I have an x squared, from here I am subtracting the left-hand side. 0, x squared minus x, minus 6. Okay? In factored form, your 2 possible solutions were 3 and negative 2. But when you check them back in, negative 2 is extraneous. So x equals 3 is your solution. Okay? So again, recap of the first 3 were from the last formative. Okay? So if you still got those 3 wrong, you didn't look at the feedback from the first formative at all. Okay? The next 3, just minor issues that I saw, okay, which are fixable. That's why we have practice, okay? So if you take out the notes that you just picked up, the 5.4, this is the last part of solving, okay? So you can put the blue sheets to the side and pay attention to what's going on, okay? Put the blue sheets to the side, and I'll talk about the first question on that in a little bit. Right. And your quiz is Friday, okay, on 5-1 to 5-4. This is very, very straightforward and very easy. But throughout this whole few lessons, I've been talking about the same base, okay, the smaller bases of 2, 3, 5, 6, so on and so forth, okay. The bases mean a number raised to an exponent. So 2 squared gives you 4, 2 cubed gives you 8, 2 to the 4th gives you 16. We could also use 4 squared, but we have a smaller base that way, okay. So anytime you're solving exponential equations, if you have the same base and they're raised to specific exponents on either side of the equal sign, you could drop those exponents down and just solve. Okay? So for example, say if you were given 2 to the x plus 6 equals 32. As of right now, most of you guys might say, hey, put it in your calculator, y1, y2, and see where they intersect, which is correct. You could do it that way. We haven't learned logs, which is the inverse of exponentials, so which those of you continuing to pre-cal will learn that, okay? You could solve it that way. So for now, in order to solve, we have to rewrite the problem with the same base, okay? The base meaning 2. So if you look at 32, you want the same base of 2. 2 to what power gives you 32? 5. So I rewrite 32 with the same base of 5. So since I have the same base of 2, 2 to the 5th, since I have the same base on either side, I am able to drop down those exponents. So x plus 6 equals 5, and then I go ahead and solve for x. That's it, plain and simple. So if we look at the first one here, we have 4 to the 3x plus 5 equals 8 to the 4x minus 3. So what base does 4 and 8 have in common? 4 to some power will not give you 8. Okay, I'm glad you said that though. 2, right? Because you're looking at the base being a number raised to a specific exponent to give you 8, okay, or 4. 4 raised to the first power gives you 4, but 4 squared gives you what? 16, so you would never get to 8, okay? And Louise, thank you for working through that because that's some of the common mistakes I see. All right, great job. All right, so how would I rewrite 4 with the base of 2? So 2 to what power gives me 4? 2. So I have 2 squared, and then I have 3x plus 5. Okay? How would I rewrite 8 with the base of 2? 2 to what power gives me 8? The third. Okay. Now, if you were to see this on exponent properties, right, what would you do with those? Yep. Multiply. So 2 times 3x plus 5. So what do I have to do if I'm multiplying? Distribute. So I have 2 to the 6x plus 10 equals 2 to the 12x minus 9. So from here, I have the same base on either side. I'm able to drop down those exponents and solve. So I have 6x plus 10 equals 12x minus 9. And I want to solve for x. What do I get when I solve for x? Fraction form is fine. Nolan? 19 over 6. So x equals 19 over 6. That's all we're doing. Okay. So in B is very straightforward. We have all the same base, meaning all 3's. Okay. So technically we could just bring these guys down. But what do I have to do with these two? add them, because when you're multiplying with the same base, what do you do with the exponents? Add. So we have negative 2x plus 1 plus negative 2x minus 3 equals negative x. And I just put them in parentheses just so you could see the expressions. Now what do I do? Yeah.
Yeah. I guess add 2 to both sides. Never mind.
Combine like terms. Good. So negative 2x plus negative 2x. 1 plus negative 3. Negative x. Okay. Add the 4x. Or it doesn't matter. You want to get your x's to one side and your numbers to the other. Okay. End up with x equals negative 2/3. Okay. So this will also help you with when we have to evaluate and looking for the same base, like the perfect roots. That's what you're really looking for. Okay. So if you turn the page, okay, whole different practice we have here. Okay. So if you look at number 2, okay, we have 3 to the 2x minus 1 equals 3. Well, what does that have an exponent of? Yeah, 1. So you have 2x minus 1 equals 1. Okay? 2x minus 1 equals 1. What does x equal? Yeah, Addison. 1. Okay? Again, very straightforward. Now, what would happen in number 8? We have 3 to the 2x minus 4 equals 1. Sawyer? Why? Excellent. Good. So, you have 3 to the 2x minus 4 equals 3 to the 0. Okay, because 3 to the 0 or anything to the 0 power equals 1. So now am I able to drop my exponents? Yep. For number 8, what is your final answer? Yeah, it's x equals 2. Good. All right. Look at number 11. Okay, you want to try to stick with your whole number exponents. So 1/3 and 9 have what base in common? Danielle? Okay, so we know both sides has a base of 3. 9 can be written 3 to what power? To what? Second. It's okay. Okay, now to get 1/3, it would be 3 to what power? -1. Good. So now that my bases are rewritten, okay, I can multiply -x minus 2 equals 6x. What do I get for an answer for number 11? Yeah, Addison. Careful. Not 7/2, but it's okay. X equals -2/7. All right. So we're going to try a few, rewriting the same base. Okay. Let's circle the ones in a different color. The bottom row we're going to do together. Okay. But for now, number 1, number 4, number 6, 7, 10, 12, 14, 15, and 16. Okay. So the ones that are circled on the board, 1, 4, 6, 7, 10, 12, 14, 15, 16. Okay. Take a few minutes to go through those. All right, let's go through these. For number 1, correct. X equals 2. How many of you did get that correct? Good. Okay. Number 4, good. X equals 13/4. How many of you got that? Okay. For number 4, it should have been pretty straightforward because the bases are the same. So you're just dropping those down and solving for X. Okay. For number 6, good. X equals 8. How many of you did get that? Good. Okay, we had to rewrite 27 to 3 to what power? Do you know? The third. So you have x minus 5 equals 3. Add 5, and you got x equals 8. Number 7. What happened, Nolan? You are correct. It is no solution. Why, Nolan? -1 does not equal -4. Our x is canceled out, so therefore there's no solution for number 7. Number 10, good. 3/2 is the correct answer. Any questions on number 10? Okay. Number 11, nope, we did that one. Number 12 is what? Esteban, what you get for number 12? Okay. All right. Assad, what you get for number 12? Okay. Nolan? -1/7. Okay. Danielle? -13/7 is the correct answer. Okay. So we have 1/4 x minus 1 equals 32 x plus 3. Okay. So looking at 32 and 4, what base do they have in common? 2. So I know this is 2 to some power equals x minus 1. This will be 2 to some power equals x plus 3. So 2 to what power will give me 1/4? Yeah. -2. 2 to what power will give me 32? Yep. What is it? The 5th power. Yep. So now we distribute. -2x plus 2 equals 5x plus 15. Okay, we have to remember we're distributing all the way through. So from here, add the 2x or get your x's on one side, get your numbers on the other. Okay, we have, hold on, 7, oops, 7x equals -13. Divide by 7. -13/7 is your correct answer. Okay. Number 14 is correct. 10/7. Okay. Because 125 and 5 have 5 in common. So just rewrite 125, 5 cubed. Number 15, good, is negative 2. Okay. 16. Okay. We have 1/4 x equals 8 to the x minus 1. 4 and 8 have what base in common? Rosanna? 2. So 2 to what power gives me 1/4? Negative 2, good. 2 to what power gives me 8? 3, good. Okay, so we have negative 2x equals 3x minus 3. Okay, subtract the 3x. Negative 5x equals negative 3. Divide by negative 5. X equals 3/5. Okay. Yep. Yep. How many of you got all of those correct? Okay. Not bad. 1 wrong? Okay. 2 wrong? Okay. 3 wrong? 4 wrong? Okay. Thank you for your honesty. You guys that raised your hand. Just to try to gauge who's where and why. Okay. What's going on there. So those of you that had 3, 4, or more wrong, do we understand where our mistakes are? Yep. Because 2 to what power will give me 1/4? We're rewriting it. So it's the same base. All right. Now that last row, 17 through 20. I'll only do a few of these. Okay. If we look at number 17, okay, we have 3 to the x equals 3 times the square root of 3. Well, do we have all the same base? Yeah. So we have 3 to the x equals 3 to the first times 3 to what power? How can I rewrite square root of 3? Yep. 1/2. So if I have 3 to the x, now, with the same base, what can I do with my exponents? Add. But what do I need before I add? Good. So we have 3, 2, 1/2. So we have 3 to the x equals 3 to the 3/2. My bases are the same. So I could drop those exponents down. So it's everything we've learned in terms of exponent properties, but now we're taking it a step further by rewriting it with the same base. Okay? So I want you to try 18. 18 only. Okay? Just try 18. You could do the rest if you choose to, but 18 is the one we're going to go over. All right? Who has an answer for 18? Assad? X equals 5/2. How many of you got that? Okay, so how would I rewrite? We have 5 to the x. Now, equals. How would I rewrite 25 with the same base? Go ahead. 5 squared. Then how would I rewrite the square root of 5? Go ahead, say it. 5 to the 1/2. Then I need a common denominator, which is 2. Okay, so I have 5 to the x equals 5 to the 4/2, 5 to the 1/2. Therefore, x equals 5/2. Okay, all right. So again, just to get familiar with, okay, the same basis, okay, you could also use these two if we go back to the formative. How can I rewrite 27? Yeah, 3 cubed. Now in this case, what can I do with those exponents? Multiply. What's 3 times 2/3? 6/3, which then reduces to what? Is that the same answer we got? Yeah. So that's how you could rewrite. Just like 125, negative 2/3. How can I rewrite 125 with a small base? 5 cubed. Okay. Then, what do I do here? Multiply, what do I get? Negative 6/3, which then is what? Can't have a negative exponent. 1 over 5 cubed squared, which is the same thing we got. So this is just another method to solve instead of rewriting. Okay? Questions? Okay, the last 2 things for today are at the bottom of the page is just solving our word problems. Okay? Knowing the steps, you need a calculator for 1 and 2. Okay? Knowing the steps of how to solve what you're setting up for. Okay? So all we're going to do is 1 and 2, use your calculator. The first one you're finding the volume. The second one you're finding the time. Okay? Go ahead, set up 1 and 2, and solve it. We're going to go over those answers before I tell you what the homework is. All right? All right. So, number 1, you're finding the volume. Anyone have an answer for number 1? Louise. 729. Good. Inches cubed. What do you have to do first? What's that? Divide by 6. 81 equals B 2/3. Then what do we do? Danielle? Oops, yep, you're right, sorry. Okay. So then from here, it would be the square root of 81 cubed. Typically when we're solving, we must include what if it's an even root? Plus or minus, but since we're talking about volume, do we care about the negative? No. So the square root of 81 is 9. 9 cubed gives us 729. Good. Okay. Number 2. What do we get for an answer? Caitlin? 14 hours. Excellent. Okay. 14 hours. How many of you did get that? Good. Perfect. Okay. You substitute in the volume, which is 549 times 5 minus 1. And it was 4 to the 1/3 or the cube root of that. All right. Good. So your homework is the blue rational exponent puzzle. Okay, that you started. Okay. Then on page 5 of your note packet, page 5, where it says 6.6, okay, just at the top, it's the circled problems. Okay, so a little bit of solving, not a bit of solving, both with radicals or rational exponents, then it gets into what we did today. Okay, so the circle problems, if you need to use a separate sheet of paper, I highly suggest it. Okay, pay attention to the directions. So these 2 are your homework.